Oh, hey, practical effects. Diamonds are not forever chemically. So, chemically speaking, when something is stable, it, in our normal environment, doesn't want to degrade into something else. Diamond is not one of those things. At standard temperature and pressure, Earth temperature and pressure, as we define it, diamond wants to chemically turn into graphite. But we never see it do that. Why? Well, let me draw you this awesome chart as to why. Here. So let's imagine this as the curve of stability. Down here is metastable. It is a low energy state, but not the lowest possible energy state. This is metastable. This is unstable, and this is stable. Now, in this context, diamond is right here in metastable, and graphite, like you'd find in pencils, is right here. Pencil tip, eraser, those colors should be reversed. Now, why, if it's not chemically stable, why doesn't diamond transition into graphite? Well, that's because there's this energy barrier here. So, diamond is kinetically stable, meaning that the energy you would have to put into diamond's carbon bonds to push it over the metastable hill into unstable and down to stable, it's too much. At standard temperature and pressure, diamond does not overcome this hump here and go down into graphite. So, diamond is not forever in different conditions chemically, but it is forever kinetically here on Earth at standard temperature and pressure. Otherwise, if you put it in a high heat environment, for example, diamond would just naturally degrade into graphite. But that is a very, very long catchphrase that I don't think De Beers or James Bond would go for. I say adopt it anyway. Hello, and welcome to another edition of Because Science Live, the show where we take everything that we are doing on this channel, on YouTube and Facebook and Twitch, and we extend it out and make it all happen in real time so I can take your questions and nerdy comments and hopefully come up with something that will add a little interestingness to the end of your week. It's not pre-recorded. Trust me. I just bit my tongue, and it's really hard to speak. I wouldn't be doing this otherwise. Aaron, we got some questions rolling in. Hit me.
Oh, we got questions.
We got questions.
Okay, this one comes from Wolf Jenkins.
Wolf Jenkins.
Could Magneto lift Thor's hammer?
So what I've always said about Thor's hammer, if it is shaped like this, yeah. I've drawn this hammer enough times that I know what I'm doing. If Thor's hammer is something like this, what I've always said is that to make itself heavier in response to someone picking it up who is not worthy, whatever that means, it emits, and remember, this is just for exaggerated effect, it emits graviton particles. Now, graviton particles are a theoretical particle that we think may transmit gravity. We have not discovered any of them yet. It's just a theory. A science theory. So, if it could emit more graviton particles, it would have more mass or be more massive, so it wouldn't be able to be picked up by the same force. I think this only happens in response to this worthiness check. So if Magneto could surround this hammer with magnetic field lines, and he wasn't trying to wield the power of Thor, I believe these magnetic field lines could still interact with the metal in such a way that it could be moved or apply a force to it. I don't think that is out of the realm of possibility. In fact, it has even happened in the comics. So I think the point here about who can or can't lift Thor's hammer really hinges on if they are trying to wield the power of Thor. As Tony Stark said, you put the hammer in an elevator, what happens? The elevator still goes up. It's in the Avengers, one of them. The Infinity War trailer looks pretty cool.
Yeah, is that today? A lot of good Spidey hair.
How does Captain America stop that hand? You know what? Next question.
Okay, cool. David Esposito says, does having super speed also mean having super strength?
Good question. So in my super strength episode, I did not get into super speed. I mentioned super density. Because if you're going to punch something like a wall, your hand is going to need to be very dense if you're applying a lot of force to it, or else it's just kind of going to smush. That being said, super strength would really depend on super speed. If you are not increasing the diameter of your muscles, of your muscle fibers, and increasing the force that your arm could put out in your fist or whatever, then you're going to need speed. And that is because, as you may well know, let's get a little color contrast going here. As you may well know, force equals mass times acceleration. So the faster something is changing its velocity for a given mass, the more force it will have behind it. Yeah, the more force it will be able to apply to something. In equal and opposite reactions. So that's why the Flash, even though he's kind of a scrawny guy like me, he can punch theoretically so hard, infinite mass punch, because he can go so fast. For us, if we really wanted super strength, it would probably be modulated by velocity, because we're not getting bigger like the Hulk, increasing mass. Have to increase acceleration. What else we got?
Gary Matthews asks, thoughts on Annihilation's shimmer refracting everything, even time and DNA?
I haven't seen it.
Okay. Sai says, how does the Venom symbiote work? Could be a good episode.
Probably be a good episode. I've gotten the symbiote question a lot. I don't have a whole lot to say on it without seeing the movie, but nature has a lot of fantastic symbiotic relationships between all manner of creatures, and I don't know any that go... Well, one's really interesting. There's a salamander that has incorporated bacteria into its skin that are photosynthetic, and it gets energy from these photosynthetic organisms in its skin. It's a symbiotic relationship that's not intentional. Evolution is never intentional. So, depending on how the movie says the symbiote suit works, I think we can get into it. But it's hard to do any numbers here without seeing the movie first. Well, don't worry. I'm a Tom Hardy fan. We'll get there.
Cool. If you have seen A Wrinkle in Time, or I guess by that logic read it, is teleportation by quantum entanglement or tessering possible?
Yeah. So there's a problem with entanglement when you're talking about quantum mechanics if you want to transmit information. So a message, or zeros or ones, is what we think of as information. But if you want to transport a person, that person would also have to be turned into information to be transmitted across a distance, like Star Trek style. The problem is, in quantum mechanics, there's a no communication theorem. So as far as we know, the principles of quantum mechanics forbid information from being teleported across massive distances via spooky action at a distance. We've done quantum teleportation from the Earth to orbiting satellites, but that information at the satellite still has to be sent around the entanglement. So, for example, you can change the state of one electron inside of a satellite to match the state of an electron at the surface of the Earth, like its state is being teleported, but we still have to tell the satellite some information so that the state will be the same. It's very complicated, but that all goes to say that we don't know any way around that communication theorem right now, as far as I know, that you could transmit a person across distance without having to do anything else. It's alluring, and I think so many sci-fi stories do this, but I don't think it's quite figured out in principle. What else we got?
How could a power suit force field work?
Force fields are weird. They're a mainstay. They're a mainstay of science fiction, but force field implies that it can apply a force to incoming projectiles, let's say, just kidding. Let's say a bullet. So if a bullet is coming in with some mass and acceleration, velocity, it's going to be able to apply some force to this force field. Now that force field has to also be applying a force to something to slow that object down or to stop it. What could this be? Well, it's not just going to be force in general. It has to be something applying that force. So this is some kind of electromagnetic field. In theory, you can do this at the smallest scales. If you have an electron, let's say we have a magnetic field here. A moving electron in this magnetic field, moving to the right, can have its path distorted by the field. It can change the way that that electron is moving because it has a charge and the electromagnetic field interacts with that charge. This could be some kind of force field. So imagine a spaceship with a electric or magnetic field surrounding it. If it had something like that and it was powerful enough, it had enough energy behind it, then incoming charged particles, like from, say, a photon torpedo or a proton torpedo, those particles could be deflected away or at least have their paths changed by this force field. Other than that, I'm not really aware of much that can be invisible and also apply a stopping force to something. What's next?
It's Moses Michael asks, could diamonds cut vibranium?
I don't know. On the Mohs hardness scale, MOH, diamond is the hardest material that we know of on Earth. I'm so sick of thinking about vibranium. There's so little known about it, it's very hard to do any kind of science-y, science fiction-y analysis of it. It definitely doesn't have a hardness, like a Mohs hardness scale, which if it did, you can kind of give a comparison because diamond is the hardest thing. It will scratch most other things. But since we have no idea what the hardness of vibranium would be, it's impossible to say. But I'm going to say, who knows? Next question.
Big Beast Gaming asks, Kyle, how close are we to Ready Player One like gaming tech?
Where I think what's the holdup? What's the point at which we can say, oh, we're in the Matrix or we're in Ready Player One or something like that? I think it's just going to be a graphical problem, which we are rapidly getting better and better at. So we already have worlds that are digital that connect millions of people. We just aren't fully immersed in them Ready Player One style because the graphics and the visuals don't confuse our minds enough. And I think we will probably get to a point, if there is economic incentive to do so, where graphics will be good enough we won't be able to tell the difference, and then I think we will start having some of the problems that are hinted at in science fiction, where we might kind of lose ourselves in it a little bit. I was playing Uncharted 4 for the first time, and there were points where my mind couldn't tell if it was actual live action footage. And it was awesome, but it was also scary. Would you want to spend your... Yep, no, I would.
Really?
I don't know, man.
Would you want to upload your body and your consciousness into a machine and live forever? A couple people have asked that.
What do I want to live forever?
Well, would you want to upload your consciousness into a machine?
I want to live long enough to see the Earth from space. After that, everything's on the table, baby. What's next?
Cool. Thomas Huber asks, how does Iron Man's bleeding edge armor work, and could nanobots in our body ever be possible?
Well, we are experimenting right now with nano machines. Things, I mean, they're not like machines that we like you may be envisioning. Nano machines right now are very simplistic. But we are experimenting with putting, say, nano machines inside of a person's blood to detect certain cells or pathogens and deal with them. That technology is generations away from what Tony Stark is doing, having billions or trillions of nanobots that he can control at a whim to create structures that are coherent, that have electronics running through them. It's an amazing technology. I don't think we're even close to anything like that. And where do they all go? Nanobots are on the scale of, as you may imagine, nanometers, or a billionth of a meter. That's really, really, really small. So, if you line them up, 1 billion nanomachines could fit in 1 meter. Now, if Tony Stark has enough nanomachines in his body to come out of his body and create a full suit, he has billions or trillions of machines in his blood or in his body somewhere. Where do they go? And how do they come out? Of his pores? A, gross. B, how much do they weigh? Does he weigh more? Does he set off metal detectors? These are all questions that we can cover later.
Yeah, I mean, you're supposed to answer those questions, right?
Like right now?
In general.
Hey, what do we got next?
Thumblethumb asks, what would happen if Bruce Banner hulked out while shrunk wearing the Ant-Man suit? Could he shrink as the Hulk?
What? Yeah. Well, we went over this in a previous live, but I think if you were the Hulk, you would still have to wear the Ant-Man suit because you have to be subjected to these Pym particles, whatever they are, and they have to shrink the distance between the electrons in your atoms and the nucleus of your atom so that you can shrink down. If the Hulk was exposed to those, it's the same thing. He still has atoms, so he could still, in theory, shrink down. But could he increase in size after that? I don't know. I think he might rupture the suit like he ruptures his pants, and then he wouldn't be able to breathe.
Yikes.
You can watch my Ant-Man episode for more on that, but it'd be a tiny, suffocating little green boy. Don't want to see that.
Hard pass.
Infinity War Part 2?
Who knows?
Hey, anything's possible in this MCU. Am I right?
Yeah, you're
Next
right.
question.
Admiral Aqua asks, if a spaceship blew up in space, could you hear the explosion?
I'm just kidding. Nothing cut out. So, the most famous tagline in all of movies is probably, in space, no one can hear you scream. And that is because, as you may already know, there are no air molecules. You son of a gun. There are no air molecules in space through which, when you make a sound, you push air with your breath out of your face. And this causes air molecules directly in front of that to bunch up. And when you look at this macro scale, this creates a wave. And we call these waves pressure waves, and we call those sounds. In space, there's not enough of this to make pressure waves as we know them. So if something blew up in space, let's say there's a lot of fuel and the cabin is pressurized, this all expands and is pushing on nothing. So unless it was close enough for the explosion to physically touch another spaceship, some of the debris, or it was close enough that some of the debris, flew out from the destroyed ship and hit another ship, no, it would not make a sound. We've even blown up nuclear weapons in space, and there's no shockwave because there's no air up there. Yeah. Pretty cool. What's next?
Professor Porgs asks, you said that super strength is something you wouldn't want. What other superpowers would you not want?
The super strength episode you all liked enough that I might do more of a series on this than superpowers you don't want. I don't like being negative. I like trying to find things that are possible or how would they work, but debunking always does better for numbies. What other superpowers would you not want? Well, the next one that I would do that I've already been asked to do is probably super speed. And the easiest way, the most fundamental thing that would be a hassle if you were moving around at super speed is just air. and just the things in the air. If you are going close to the speed of light, like you want to be, if you want super speed, you want super speed. So you're going to be going close to the speed of light. Let's just say you're not going to go beyond it because you can't, as far as we know. The speed of light, 300,000 kilometers per segundo. Now that is very, very fast. If you're going close to this, air itself is bunching up and heating up because it's being compressed so much that the surface layer of your body is going to be flashed into plasma. That's bad enough. If you hit a bug, it's going to be a tiny explosion, a tiny fusion explode. You are moving so fast at this point. If you just went, oh, I think I'll just grab some milk. If I went from here, if I started here, and I just ran to here at the speed, at or near the speed of light, by the time I got here, I'd be creating a fireball of X-rays and fusion that would be destroying this entire space that I'm in. I'm not in a studio. I'm in a black void with nothing all around. But I would be destroying everything around me. Even if you were going in space, it's so bad that there's no air in space. But there are enough particles in space that if you went near the speed of light, it would start to degrade your body. In space is the ultimate nothingness. There's almost nowhere that you could go your full speedster speed and not be annihilated by interactions with small particles. Doesn't sound fun. But if you just move pretty fast, it'd be all right.
It'd be fine.
Don't give anyone a high-speed high five. Oh, pretty cool. What's next?
Chance Hibbs asks, what would happen to the Earth if a second moon suddenly appeared in our orbit like at the end of the movie The Fifth Element?
Getting a lot of repeat questions. But that's cool. So we covered something like this on a previous live episode, but if another moon appeared in our orbit, it would change how we orbit. It changed our orbit system, how we orbit the two moons and how we orbit the sun. Very basically. But go watch the other thing. What's next? Come on,
I know you don't want to know about Vibranium.
No.
Can Black Panther charge himself up by punching himself?
Yes? I don't want to think about it anymore. Yes, because his body is still... There's an outside source of energy, which is his inside of the suit body, which is still supplying the energy that he is turning into kinetic of his fist and then potential of the... I think so, but no more Vibranium questions, please. But yes. What's next?
Intellect123 asks, the phasers in Star Trek, are they theoretically possible with all the sightings included, like stun, kill, totally vaporize?
It's a good one. That's so good that I'm actually gonna do a phaser episode pretty soon, more specifically the one on totally vaporizing someone or something. And the takeaway is that, I'll just kind of lead you along the thought path here. If you totally vaporized something or someone, what does that mean? It means turning their solidness into vaporness. And as I explained in the lightsaber episode and the xenomorph versus lightsabers episode, when something goes from a solid to a gas very quickly, it expands a lot. And in all directions, and very, very quickly, and explosively. I think you know where I'm going with this, but I'll get to that in a future episode. Probably. Good idea. Also, keep asking me good questions here and in across Because Science Properties, because I have at least 2 or 3 episode ideas that I have put on the docket just because you have asked awesome questions. I'm serious. And if you ask here, we'll try our best to get your handle or at least mention you that you put the ideas, so keep them coming. I love it. It's about a third of my episodes have to do with things that I've been asked, so keep them coming. What else we got?
Titus asks, does DNA contain genetic memories to the extent shown in the Assassin's Creed series?
No. Well, I mean, the Animus in Assassin's Creed is a very interesting concept. The closest thing I would put to genetic memory, no. The closest thing I would put to genetic memory would be epigenetics. And epigenetics is the study of how our genes change in response to environmental exposure. So you are not just nature, you are nurture too. The genes you are born with, from the instructions from your DNA, change throughout your life in response to how you interact with the world. If you are in a different environment, have different experiences, different inputs, different stimuli, it changes how these genes are expressed, turning on or turning off. So there was just that twin study from NASA where the two Kelly twins, one was up in space for a year and one stayed down here on Earth. A study came out showing that the epigenetic differences were up to 7% or something like this. This is just, I mean, it was overblown in the media, but this is just to say that space, being in space, changes how your genes are expressed. Now, if you want to extend this out to some form of memory, how the different expression of genes could be a roadmap of what kind of experiences you've had, I think that's pretty close to what the Animus means, but the technology for recreating entire lifetime histories from what genes are flipped on and off, I think is only... The leap in technology would have to be absolutely enormous, and it probably wouldn't be the full story. You couldn't just look at DNA. But epigenetics is really cool. That's all I have to say. I'm a shill for big epi. What else we got? Got time for one or two more questions. So get them in.
How could we restart the core of Mars to keep a hydrogen atmosphere?
There is an atmosphere on Mars. It's very, very thin. That's why you need to attack it kind of when you're entering. You have to go at a very shallow... When Elon Musk wants to go here to Mars on the red planet because the atmosphere is so wispy like this. Man, people who don't watch Musk Watch must be very confused.
Good plug.
Yeah, watch Musk Watch, it's fun. There's a very wispy atmosphere on Mars, so if you're approaching it, you kind of have to skim this wispy atmosphere so you can slow down enough over time that you don't impact it at, thousands of meters per second and explode. So there is an atmosphere on Mars, but we want more of an atmosphere on Mars so we could live. I know people have toyed around with a lot of different geoengineering principles for that, from nuking it to adding greenhouse gases and stuff like that. I haven't actually heard about restarting the core. It doesn't not have an atmosphere, and it does not have an electromagnetic magnetic field around it. I'd have to look into that. I don't know. It's not going to be nukes, probably, because you still got to drill down there. We can't even drill more than a few kilometers down into our own crust of the Earth. We have to figure out a lot of stuff. Mars is not plan B. We got to figure out Earth real soon before we can just restart the core of a planet, although it does sound cool. One more question.
One more quickly
question.
Could the Flash split Earth in half by just running on it?
No, what would happen first if the Flash was running fast enough was that each step would be imparting so much force to the ground that eventually he would probably get to a point where the next step he took would launch him into space. But that sounds, again, like another episode. He'd have to constantly be applying more and more force, because the closer you get to the speed of light, hey, look at all this, the more energy you have to put into your motion, and that goes up into and up close to infinity, the faster and faster that you want to go. So more and more force. He'd probably fling himself off the planet before he destroyed any planets. And that's all the time we have for this episode of Because Science Live. Thank you so much for all of your questions. I've been having a great time with all of the new formats that we've been doing, from this to the vlogs, and all of you who have already subscribed, thank you so much. I didn't mention it last time, but we're already at over 200,000 subscribers in just a month. That's awesome, and it shows me that you want to see more of this, so I'm going to keep doing more of this, and, you know, keep those comments, questions, and concerns coming, because I read most of them, especially on the new episodes, within the first few hours of posting, so get them in, and I'm more likely to answer them on the vlogs. Thank you so much. Have a wonderful weekend, and be nice to each other, because this is all we got.